Hello, and welcome to our presentation on our term project, the Automatic Fruit Picker. My name is Andrew Pulley.
My name is Brandon Fong.
I'm Brian Ngo.
I'm Pedro.
Fruits and tall trees are hard to reach. There exist devices to lift farmers closer to fruits, but it puts them at risk of falling. Manipulating objects at such a height can prove to be difficult and dangerous as well. Our project aims to solve this problem with a device that can be operated from ground height and automatically harvest the fruits. It also contains a built-in safety that disables the cutting mechanism if a pole is dropped or aimed below a certain angle threshold. Here is a closer look at our design. You can see that it is a basket attached to a pole with shears on top. The shears are actuated by the two servos in the rear. A sensor at the bottom of the basket detects the presence of a fruit and tells the servo to move.
The sensors we used were a reflective infrared optical sensor to detect when the fruit enters the cutting area, and also a gyroscope and accelerometer to measure the tilt of the pole. From there, the data is analyzed by code written in CircuitPython on an Adafruit Feather M4 Express. This microcontroller then outputs commands to a driver board, which powers two servo motors that actuate the cutting arms. For the sensors, we used an ITR 20001T. This is a miniature infrared optical sensor which detects when objects are in front of it. According to the product page on the Adafruit website, this sensor works best when detecting objects ranging from 2 to 10 millimeters in front of it. This sensor will be used to detect when a fruit is within cutting range of the shears. The other sensor we used was an Adafruit MPU6050. This is a gyroscope accelerometer combination sensor. This sensor is used to monitor the angle of the pole and to make sure it is being held vertically. If the measured angle is too low, the cutting arm stops. For example, in the case that the pole is left on the ground and a child accidentally activates the sensor with their hand. In this case, the shears will not activate. For the actuator, we used a DSS servo DS3218. This is a high torque servo capable of outputting a stall torque of 20 kilograms at 6 volts. We used two of these servos, one for each cutting arm. This servo also has the added benefit of being waterproof, so it will not be affected when harvesting fruits that may be wet due to rain or dew. The driver board we used to control the servos is an Adafruit PCA9685. This driver board is capable of powering up to 16 servos at one time. However, we only needed to power 2. It can manage an input voltage that ranges from 4 volts to 6 volts and uses 25 milliamps of current per servo.
In our regards to our code, we basically constructed a function and named it up_to_value. What this function does is that it would analyze if the up_to switch was being activated or no, which meant that there was a fruit inside the basket, and if it was being activated, it would cut the branch, leaving us with the fruit that we could bring it down. Another important thing that we added was that we added a safety measurement that included a function that, in case the accelerometer sensed that our mechanism was falling, it would activate a warning that would not allow the scissors to cut. In this way, we couldn't harm the user.
In the circuit schematic, the feather board will be powered by an external power source through its USB. The servo driver board and the accelerometer are going to be connected to the SCL and SDA pins so that we can utilize timing as well as communication through the boards. The optical reflector will be controlled using a digital pin set as an input to detect if the voltage is high or low. The optical reflector, accelerometer, and servo driver board are going to be powered by the 3.3 volt pin from the feather board. The two servos on the servo driver board will be powered by an external battery source, which contains 4 1.5 volt batteries in series, which gives us 6 volts. The maximum voltage that the servo can take is 6.8 volts, but for our purposes, 6 volts is sufficient. To control the current going into our D5 pin on the feather board, we place the resistor in series with the auto-reflector to lower its current to 7 milliamps. What I learned through this is the thought process that goes into choosing specific parts and how to determine the specifications we want. I found that sometimes we need to compromise and use what we have at our disposal in our designs. I think if we were actually able to build it, we would be able to make more fine-tuned adjustments such as timing and whether or not the wiring would fit neatly into our design.
This is the end of our presentation. Thank you for watching and stay safe.